presentation. It is really, it is a must, not option. Now we will go to the second speech. Will be presented by Dr. Ibrahim El-Agawany. Dr. Ibrahim is a senior manager at Energy Recovery. He holds master's degree in business administration from AACT and graduated in mechanical engineering from Alexandria University. He has over 20 years experience in water treatment field and reverse osmosis technologies. He contributed to several mega projects with international companies. His experience in this business involved roles at technical consultant level, developing and delivering technical services for a wide diversity of energy recovery clients. Dr. Ibrahim has been one of the committee members of ASWTA Award Water Treatment Competition since it started in 2020. Dr. Ibrahim will present a presentation titled Efficient Water Supply Resources, Green Hydrogen Application. Yes, please.
Dr. Kamal, thank you for the introduction. I'm just not a doctor, I'm just an engineer with a master in business administration, and my background is mechanical engineering. So, just to make clarification. Dr. Engineer, thank you so much for the opportunity and all the effort done by you and your team for this successful event. Thanks so much. So today we have Toa. Ready? Okay. So today we are going to introduce the idea of green hydrogen, or how it's like what the need for the green hydrogen to be produced, and we are going to have the details on the ultra pure water for green hydrogen production. We'll go fast through the benefits of using energy recovery devices for producing ultra pure water. Also, we have major global green hydrogen projects that somehow planned worldwide, and we may have one of the potential that may be executed in Egypt, but this is out of the listed projects here in my presentation. So this is just 3 types of hydrogen production. We are talking today about the green hydrogen, but this is coming from when we are using electricity to electrolyze water to get hydrogen and oxygen. But we also have many colors of hydrogen that can be introduced in a different presentation. One of them is the gray hydrogen, which is using natural gas, that is the source, and also blue hydrogen. But the difference between blue hydrogen and gray hydrogen is that the CO2 emissions coming from the gray hydrogen can be stored and can be considered as blue hydrogen. So in this slide, we may take a little bit more discussion. So we need ultra pure water and electricity to go through electrolyzer to get hydrogen and oxygen, and then we need this hydrogen goes through hydrogen fuel cell plus oxygen as well and electricity to get electricity and a byproduct as H2O or water. So in this process, the first process, we need a lot of energy, more than the produced energy out of the hydrogen cell. So mainly ultra pure water with a much more electricity that makes this efficient, not very much efficient system to get electricity out of the hydrogen. Although there is benefits of having talking about sustainable energy and going into more sustainable environment, and Egypt is one of the countries that we know that from the Ministry of Petroleum that we are looking into 5 to 8% of the market up to 2030 global international hydrogen production worldwide. We are also looking into exporting hydrogen and internationally. And one of the zones that we have introduced is Suez Canal Economic Zone. They are looking into, as I discussed with Mr. Kamal, Dr. Kamal, that there is a potential that there is a pilot plant to even use green hydrogen as a fuel for marine industry. So to make the system a bit more efficient in the scope of water treatment or in the scope of getting ultra pure water, we are even regardless of the source of the water, is it municipal or river or even recycled or wastewater, or major plants are considering seawater, we go into mixed bed even after 2 pass RO, or maybe different technology like only RO and mixed bed, regardless. But the idea of reaching reaching ultra pure water, it needs we consider RO or double pass RO, or sometimes in the reuse 2-stage and then double pass. So we are considering here to reach the ultra water RO. It is to reach resistivity of 18.2 mega ohm, measured at this 25 degrees Celsius. Often, this is a water that needs special treatment. So in this slide, we are talking about how much seawater would be the source of desalination or treated water. Worldwide, it is considered 65% considered in the planned list of green hydrogen system. We will list these projects later in different slides, and the recycle or the reused water would be around 15%. So in the map, we are talking about the total plants or the countries who are going to use seawater desalination as a source of production or of ultra pure water. We go more into depth or into details about getting into more efficient system. We are using pressure energy recovery devices like pressure exchanger, and the main target is to reduce the equipment capex and of course, to reduce the renewable energy footprint. Maybe I missed to mention that for green hydrogen, the source of electricity has to be renewable energy. This is a major point that I missed to mention earlier. Sorry for that. So we have challenges. All what we are talking about is more of like studies and numbers and potential and planned projects. So we see either using recycled water or seawater RO. There is challenges regarding the energy reliability and the source of water. And this is if we are using double stage RO, getting water that needs to be more treated. We are talking also about savings of energy up to 30%, from 10 to 30% when we are using double stage RO, using energy recovery devices in the system. In the seawater RO, we are talking about up to 50% and more of energy saving compared to not using energy recovery, but it is more focusing on saving power or saving the capital cost of renewable energy sources or equipment, as well as reducing the footprint of solar power plants or wind or whatever the source of the renewable energy. We are going to go a little bit faster through the slides of the pressure exchanger, and maybe some of us knows more about the PX, but for the one who doesn't know, this is an equipment that is very efficient, used in RO, in seawater desalination, and also low brackish. It's can work from 7 bars up to 700 bars or 10,000 psi. We have an equipment that can be 120 bars of as well. So it's regardless of the application, but the product is there and it can be used in different applications up to that high pressure. So on the left side, we are seeing a normal seawater desalination and without energy recovery device. And this is when we are using seawater as a source of ultra pure water. So we see that in the other diagram, we can see the energy recovery system that can reduce the power consumption up to 50–60% depending on the recovery of the system, as well as needs reducing the power consumption and the footprint of the equipment. So low pressure RO systems is a little bit different. We are considering two-stage with the interstage boost. There is a lot of advantages using interstage boost between the stages, as well as considering an energy recovery that works at low pressure, like 7, 10, 12 bar. We can see that this system, simple system integration, easy to operate at several operating conditions. Interstage booster pump is more reliable, is more flexible with the control. This is just introducing the PXQ400 that we released around more than 1 year ago. It is the latest pressure exchanger. It has better performance, and compared even to the previous model of the PX. So it is relatively up to 98% efficiency with low sound level, and lower, we reduced the mixing that is considered in the isobaric energy recovery devices in general, as well as it is the lowest life cycle cost proven as energy recovery in RO in the market these days. We are going faster a little bit but it's fine. Thank you. But just a few more slides about the global list of projects that is considering producing green hydrogen. We see as much as this is the source of GWI. There are maybe more. I know that there is a MOU between Aqua Power and Egypt to produce like around 600 tons of ammonia per year. And this plant is just like signed like last December here in Egypt, and it's like the potential is $4 billion to be invested in such in the total capacity of producing of 2 million tons of ammonia per year. So this is somehow, as you see, all the plants are considering desalination for producing ultra pure water to be used in the system for production of green hydrogen. One of them, we took Oman project. The first phase is, this is all source from GWI. This is why I mentioned that the Egypt one is not mentioned. So I just mentioned out of the slides. But this is relatively a plant that is close to the first phase of aqua power considered or MOU plant in Suez Canal economic zone. I think it's partnering with Hassan Ali. So the idea of this is the power saving. If we are not considering energy recovery, it will be the producing cubic meter of desalinated water, around 5 kilowatt hour per cubic meter. While you can reduce that to 2.3 kilowatt hour per cubic meter, and that is considered savings of 1.1 megawatt savings, and as much as solar panel surface area of around 2.2 hectare. This like surface area of solar panels is considered as footprint as and capital cost as well. The other project that is huge and it's worth mention is planned to be installed in Spain with a huge amount of power for the electrolyzer. It's 67,000 megawatts. It's something like, imagine 3,000 wind turbines, each one is 22 megawatts, or like a surface area of 670,000 acres of solar panels. This plant is considering the savings. It is requiring around 400,000 cubic meters per day desalination, and the numbers are here extreme, like showing the benefit of having a more efficient system, even without, even if it is a small amount of performance, getting better performance. So in such calculations, we are even saving like 45 megawatts and like 445 of acres of solar panels. Considering, if we considering the source of water as water reuse, this is for the ultra pure water, and the cooling towers or for cooling, this is around 1,200,000 cubic meters that to be treated, and considering reducing from 0.95 kilowatt hour to 0.75, this is can make for like 10 megawatts of savings and like 40 hectares of solar panel surface area. Conclusion: green hydrogen production is growing worldwide. It's really considered in Egypt, as I mentioned earlier, and to have the most ultra pure water from seawater, RO, we are considering being the system to be as efficient as possible. Cumulative capacity of water needed around 2.5 million cubic meters per day is possible, and this is the plan out of the list of projects that we listed. Also wastewater reuse as a source of feed water is possible as well, and it can be also considered. We didn't mention that the worldwide green hydrogen is getting more and more, considering net zero goals, public policy and regulations. Cost to store excess green energy is more achievable than a huge amount of batteries, as well as the source of water or the drought can be challenging in some areas. Using the pressure exchanger as energy recovery devices can be beneficial in the system, reducing or increasing the efficiency and reducing the power footprint and the equipment capex. Thank you.
Thank you, Engineer Ibrahim, for this presentation that prove the must of water energy nexus. We need